Here is a problem on the differentiability of a given function, and it is from the differential calculus. This problem has appeared in joint entrance exam main held on 20th July 2021 in the second shift. The problem is from the differential calculus, and it is about the differentiability, the number of points of differentiability in a given interval. The problem is, let a function g defined from the closed and bounded interval 0 to 4 to real numbers. It is a real valued function defined on the closed and bounded function of closed and bounded interval 0 to 4. It is defined as g of x is equal to the maximum of t cube minus 6t square plus 9t minus 3, where t 0 less than or equal to t less than or equal to x, and the x ranges from 0 to 3, 0 less than or equal to x less than or equal to 3. And it is 4 by 4 minus x when 3 less than x less than or equal to 4. So as t is ranging from 0 to x, including 0 and x, the function is this, and x varies from this to this, and the maximum value you have to consider. Then the number of points in the interval, open interval 0 to 4, where g of x is not differentiable is. Solution. Let f of x is equal to x cube minus 6x square plus 9x minus 3. We want to know where the maximum will be this function f of x. For that, we differentiate and take the first derivative. F prime x is equal to 3 times x square minus 4x plus 3, and when factorization takes in place, 3 into x minus 1 into x minus 3. That means x is equal to 1 and 3 are the stationary points or critical points of the function f of x. Now its second derivative is calculated, that is equal to 3 into 2x minus 4, and the value of f double prime at one of the critical points, that is at x is equal to 1, will be 3 into 2 minus 4, that will be minus 6, which is less than 0, and hence maximum, there is a maximum at x is equal to 1. And at x is equal to 3, f double prime 3 is 6 greater than 0. There is a minimum at x is equal to 3. So fx attains maximum at x is equal to 1, and the maximum value is the value of f of 1, that is equal to 1. You can see the sum of the coefficients of the function is 1. And f of x attains minimum at x is equal to 3, and the minimum value is f of 3. Please compute, and it is minus 3. And this minimum is not required. What all wanted is maximum for us. And f prime x will be equal to 3 into x minus 1 into x minus 3. Let us see what happens when x less than 1, when x less than 1, when x less than 1, it is negative. When x less than 1, it is negative. Negative into negative, positive. It is greater than 0. And when x is greater than 1, when x is greater than 1, this is positive. But less than 3, less than 3, this is negative. This is negative. Positive into negative is negative in 1 less than x less than 3. When x greater than 3, 3 minus 1 is greater than 0. This is also greater than 0. The whole is greater than 0. So that means to say f of x increases in 0 to 1 and decreases in 1 to 3, and after 3 it increases. This is what it says. It is same as the pictorial representation also says. So x less than 1 it is positive, between 1 and 3 it is negative, and x greater than 3, it is positive. So notice that f of x increases in the in 0 to 1, attains maximum at maximum value 1 at x is equal to 1, decreases 1 to 3. So by the definition of g of x, what's the definition of g of x? Recall, g of x is equal to the maximum of 0 less than or equal to t less than or equal to x when x ranges 0 less than or equal to x less than or equal to 3. So in the interval 0 to 1, in the interval 0 to 1, it is an increasing function. Therefore, the maximum is f of x only at x. For a value of x, the maximum is f of x only. Therefore, g of x is equal to f of x when 0 less than or equal to x less than 1. At x is equal to 1, it takes the maximum value 1, and according to the definition, that maximum value is there up to 3. Up to 3. Therefore, from 1 less than or equal to x less than or equal to 3, that maximum value will be there according to the definition. After that, 4 minus x when 3 less than x less than or equal to 4. So this is your g of x, g of x. And if you see carefully, you can also talk about the continuity at x is equal to 1 and x equal to 3. Now we have this function which we have already seen. Let us take the derivative. G prime x will be f prime x. F prime x we have already calculated 3 into x minus 1 into x minus 3, where x is 0 less than or equal to x less than 1, and it is 0. Differential derivative of 1 is 0. 1 less than or equal to x less than or equal to 3. The derivative of 4 minus x is minus 1. 3 less than x less than or equal to 4. Now, the possibility of losing the differentiability is at 2 points, that is at x is equal to 1 and x is equal to 3. Let's see what is the g prime 1 minus, that is the left-hand derivative at x is equal to 1. The left-hand derivative means when x approaches 1 this way, from left. So the value will be x minus 1 x is equal to 1, you substitute here, that will be 0. It will be 0. And the right hand derivative, x approaches 1 from right, the value is 0. So g prime 1 plus that right hand derivative at 1 is equal to 0, and they are equal. The left hand derivative and right hand derivative are equal. Therefore, your function g of x is differentiable at x is equal to 1. What happens at x is equal to 3? Now g prime 3 minus, that means left hand derivative x approaches 3 in this direction, the value is 0, and when x approaches 3 from right hand, the value is minus 1. So g prime 3 plus right hand derivative is at 3, the value is minus 1, and we see they are not equal. They are not equal, and hence g of x is not differentiable at x is equal to 3. In the interval 0 to 4, open interval 0 to 4, the only point where the differentiability is lost is x is equal to 3. Therefore, our answer is the number of points in the interval 0 to 4 where g of x is not differentiable is only 1. At only one point, it is not differentiable. That point is x is equal to 3. Our answer is 1. So that is the discussion of the solution of the given problem about the differentiability from differential calculus. I wish you all the best. Thank you.